Every year, floods are caused by typhoons and torrential rains worldwide, causing a lot of damage. Flood affected areas are not easily accessible by humans, and this is where drones come in. We employ unmanned drones for efficient flood detection. In 2015, the Chennai floods killed more than 500 people and over 18 lakh people were displaced, with estimates of damages and losses ranging from nearly 200 billion to over rupees 1 trillion. Over the past few years, unmanned aerial vehicles have gained considerable interest as a remote sensing platform for various practical applications such as traffic monitoring and search and rescue. We focus on the automated aerial scene classification of flood affected areas from a UAV, especially a VTOL for our project. We have come up with a design for a VTOL that can be customized, carries payloads, uses optical and thermal cameras to capture footage and images for real-time processing through a cloud-based ML model, avoids obstacles, and has great endurance. It felicitates optical flow and is designed to be controlled manually or automatically depending on the location and use case. We are here not to jump into quadcopters and just get a model made quickly. We are rather here to change the status quo in designing a VTOL that does what a quadcopter can do and even more. Every project starts with an idea, but stopping there and not visualizing it will delay the progress. And that is precisely why we built a prototype. We 3D printed a carbon body and over it made our very own aerodynamic padding and added all the other necessary motors, wires and flight control modules to make the prototype not just an ideal one but an actual working model. So what we saw was the old version. What we are to see is the new model that is under development. We have a dihedral of 5 degrees to improve roll stability, a lower center of gravity, wingspan size reduction for more preference to payload capabilities, and many more. The drone is sent to the flooded and affected region after pre-flight checks, and the camera module is all set to take optical and thermal images for real-time processing. Next up, we have used a Raspberry Pi 4B model as a microcontroller to interface the camera module. So this is used and the real-time data collection of images is done through the module. Now this is sent to Firebase where these pictures will be accessed and sent as input to the image processing modules for further analysis. We look to go for specialized cameras like the ZenMuse X-T2 to increase capture quality and resolution drastically. A semantic segmentation network classifies every pixel in an image, resulting in an image that is segmented by class. Reinforcement learning is a machine learning training method based on rewarding desired behaviors and punishing undesired ones. We also employ optical flow algorithm to accelerate learning. And optical flow or motion estimation is a fundamental method of calculating the motion of image intensities. We employ transfer learning where we use a pre-trained AlexNet model for classification and detection of floods. Transfer learning generally refers to a process where a model trained in one problem is used in some way on a second related problem. Let's see how we made it work on a video that has both flooded and non-flooded regions. You can see if the region is flooded or non-flooded and the percentage of the flooded and non-flooded regions. One of the major objectives of using the drone is to detect humans who've been stuck in the floods and are in need of immediate help. When the drone flies through the affected regions, the images or live feed is sent back to the cloud through the camera module and the Raspberry Pi module. These images are processed to find humans using the RetinaNet, a deep learning model with a ResNet backbone, which provides state-of-the-art results for aerial object detection. Whenever a human is detected, an alert is sent to the NDRF. We can also employ techniques like photogrammetry to determine the approximate position of the detected human to make the rescue more easy and efficient. We have also simulated an obstacle avoidance course and algorithm that would come in handy if the VTOL has to pass through high-rise buildings or maybe even tall trees, and sometimes it may have to pitch down its altitude for some close shots.